Where's Bobby? Huh? Have you seen Bobby?
Bobby, Bobby,
No.
Shay.
No idea. You can't read.
Bobby, Bobby, Shay.
Where's Bobby? Stop speaking. Bobby. Rubido. Have you seen your brother? Bobby.
Bobby, Bobby,
Bobby.
Shay.
Bobby.
Bobby,
Bobby.
Bobby, Shay.
Our plants are living organisms that need to be fed if they are to grow well. Like any other living organisms, our plants will be strong and healthy if they are given the right kind of nutrients. But because our plants are composed of different parts and go through different stages as they grow, their nutrition needs are also varied. Well, it's actually a bit like us. We need protein for our brains, amino acids for our muscles, carbohydrates for energy, calcium for our bones, etc. And we need these nutrients in different quantities at different stages of our life. A balanced nutrition for our plants includes basic nutrients, major nutrients, and minor nutrients or trace elements, including essential trace elements and non-essential trace elements. In what way are these nutrients important to our plants? Well, the basic nutrients, carbon, hydrogen, and oxygen, are the building bricks of plant nutrition. They are needed for the formation of organic combinations, and they are usually sufficiently present in water and carbon dioxide. Of the major nutrients, nitrogen, phosphorus, potassium, magnesium, calcium, and sulfur, nitrogen, phosphorus, and potassium are the most important. They are the same minerals we find back in synthetic fertilizers. Synthetic fertilizers are even differentiated from each other by these elements. But be careful. These nutrients are already mineralized in synthetic fertilizers. They are therefore right away absorbed by our plants without the benefit of soil life regulation. Nitrogen promotes the growth of roots, stem, stalks, and leaves. We call this the vegetative growth of the plant. Phosphorus and potassium both promote root and tuber formation, fruit development, seed formation, and resistance to diseases. While potassium in addition also provides a better bacterial life in the soil. When using synthetic fertilizers, nitrogen is added to our soil in an already mineralized form and is therefore not regulated by our soil life. Excess nitrate in our soil is therefore readily absorbable by our plants. Our plants, however, cannot convert all this nitrate into plant protein. The excess therefore remains as nitrate in our plants. When we eat these plants, we also eat the excess nitrate. The nitrate becomes nitrite in our body. Nitrite reacts with the hemoglobin in our blood. This in turn hampers the transportation of oxygen, possibly causing blue disease. The nitrate that becomes nitrite in our body also reacts chemically with aminos coming from meat and fish, resulting in nitrosamines, which are carcinogenic. Part of the phosphorus in organic material is immediately decayed and processed by our soil life through a process of mineralization, thereby converting the phosphorus into absorbable phosphate ions for the plants. Another part of the phosphorus in organic materials goes through a process of humidification and becomes organic phosphate and humus. This phosphate is then gradually mineralized by our soil life and also converted into absorbable phosphate ions, which in turn are absorbed by the roots of our plants. At the same time, acids produced through the process of decay make phosphorus that was locked up in soil and rocks also available to our plants. However, when humus decreases, so do the acids. Phosphorus then becomes locked up and our plants are bound to starve for phosphorus. This is rampant in conventional farming and remedied by adding synthetic phosphate to the soil every so often. But phosphate enrichment leads to a phosphate-saturated soil and phosphate strain. This process can be compared with a sponge in which water is dripped from above. Only when the sponge is saturated will it start dripping from below. This should be avoided because the phosphate that is washed out into the groundwater may cause an algae growth explosion that uses oxygen and other elements at the expense of other water life. Calcium regulates the pH in the soil. It stimulates conversion of organic matter into plant food. It prevents phosphate strain. And improves the supply of magnesium. Calcium and sulfur enhance the ability of leguminous plants to fix nitrogen from the air. Sulfur also helps in the water management of the plant. And magnesium enables plants to use sunlight as energy. Besides the basic nutrients and the major nutrients that we discussed so far, our plants also need the essential trace elements iron, manganese, zinc, boron, molybdenum, and copper. They make up less than 1% of our plant's biomass, but that does not mean they are not important. A shortage of one or more of these nutrients could make our plants vulnerable to diseases. And an excess of any of them could lead to the production of toxic substances in our plants, which in turn could make the consumer sick. The safest and most dependable way to ensure availability of these nutrients in our soil is to use organic fertilizers.